Hello, scientists. This is Mr. Miller. You've just watched a video that talked about the water on what we call the water planet, and that is Earth, where we live. And they said of all the water, 97% of it is salt water. So if you remember from the video yesterday about Jose Albagreen, I can't even say his name, but he drifted for over a year across the Pacific Ocean until he was rescued. And he was surrounded by salt water, but he couldn't drink it because salt water is poisonous to living things. If you pour salt water on your plants in your garden, they will all die. Likewise, if you drink salt water, you can get very sick, dehydrated, and ultimately die. Now, how big of a percentage is 97%? Think about that. Let's say I had a bowl full of 100 pennies. 100 pennies, if I reached in there and took out 3 of the pennies and set them down on the table next to the bowl, they wouldn't look very impressive. There wouldn't be very many pennies compared to the 97 pennies still in the bowl. So 3% is our freshwater supply. So 3% plus 97% accounts for 100% of all the water on the planet. Now, of this fresh water, 1% is available to us for all our needs. And it's available to all life on our planet, not just humans. 2% of that 3%, so that would be 2/3, is actually in the form of ice in the glaciers up in the North and South Pole, and it's also underneath the ground. And we call that underground water groundwater. And it exists in things called aquifers, and we'll talk about that later. So when I add up this 3% and 97%, now I have 100%. So now if I look at the 3 pennies I set aside, if I take away 2, now I have 1 penny versus all those pennies in the bowl and the other 2. I could take those 2 and throw them back in. And that's how much water we have available for use for us to survive. Now, what's the problem with that? Well, population keeps growing. And as our population grows, we need more land to farm, to produce food so everybody can survive. And everybody that's surviving has to have water delivered to them or they would have a hard time. So of the 1%, the lion's share, so the most of that water is used to generate power. And if you think of your life, how much power do you use? The answer is you use power all the time. And 49%, that's pretty close to 50%. So half of this fresh water goes to generate power. And we could talk about how they generate power. They try to conserve that water. What they do is they heat up the water, turn it into steam. They allow the steam pressure to push a turbine, which turns, which creates electrical energy. We also turn turbines through wind in the wind towers you see driving down the highway, or we have them inside of dams so that we can let water pass through and turn them to create electricity. But a large portion of the country doesn't have access to river water or winds that are sustainable, that last long enough to generate enough power. So they have to use what's called steam generation. Of the 1% available water, 31% is used in agriculture. And that's used from everything to raising animals, to raising the feed for animals, to provide materials for clothing that we wear, and also everything that we eat. And we know without food, we couldn't survive. So if I look at these two numbers, now 80% of all of this fresh water is being used up. And then if I take out another chunk, 11%, now we're up to 92% of all the fresh water that we have access to is used for public use. So that means it's delivered to houses, it's delivered to apartment buildings, cities, all around the world. And this is water used for things like cooking, cleaning, washing yourself, using the bathroom. So this is all public use. When we consider all the things that are made in this country, whether it's a car, a bicycle, clothes, all the things that we rely on and we need is produced in factories, and factories account for about 4%. So now if I look, I add all these up and you notice they don't quite equal 99 because there are some other uses. Mostly it's just waste because we're not 100% efficient in using those waters. We lose water in this process. Only 1% of the original 1% of the water on Earth that's available we have for drinking. So as a very small number, if I look at the overall, that would be 0.01% of all the available water on the planet we use to drink. Now, what happens as the population grows? Well, we need more water. So we've been pulling it out of the ground, out of the aquifers, using big wells. And unfortunately, we're depleting the groundwater. So once we deplete the groundwater, now we're going to have trouble because we only have, at best, 1% of all the water on the planet available. So what are we to do? We've talked about the need to travel to other worlds. We talked that we need water to be able to do that and survive on other worlds. But it turns out the most water we've ever found is right here on Earth, and we can't take it with us because most of it is not drinkable anyway. So how do we replenish this 1% of our drinking water? Well, we're going to talk about that in the future, but the nice thing that you should know right now is all of this is recycled. And all the water, the fresh available water we have for drinking, is the same fresh water that's been available since the earth was formed. So that means the water we're drinking, was used by dinosaurs at one time, passed through them, went back into the environment, back into the world to start a cycle, and it's purified, replenished, and it falls as rain. So we're going to be talking all about that. Please write down some of these numbers. You don't have to write the exact table, or you could copy this table. But we will be talking more about this. All right? So have a great day.